Good day, everybody. I'm going to walk you through the first problem of the photoelectric effect homework because it's not obvious how to do that. And since you're just introduced to the concept, you might be a little bit lost. Once you get through it, you really want to make sure you understand this graph and all the ways it can be related to the equation that we established for the photoelectric effect. So I'm going to put off to the side that equation because it's going to come up again. What we're basically talking about is in a photoelectric effect, you knock off electrons, and we can measure the maximum value of the kinetic energy. And we found out that that's equal to the energy of the incoming photon, so there's your HF, minus the work function. Okay, and the work function is essentially how much the electron is held into place by the atom. So it's a form of energy, okay, and we want to understand how this relates to the graph. Now, what makes this graph a little bit different, because we have seen in the notes a KE versus F graph, is we don't have KE on our y-axis. We have stopping potential, or V. And so that's what we want to be able to do, is connect this to this equation. So that's what I'm going to walk you through. I'm not going to solve the problems. I'm just going to talk to you about how to set them up. Okay, so this is again from an old AP problem. So in A, we don't want to know for a frequency of light that has a stopping potential of 3 volts, what is the maximum kinetic energy? Well, obviously we don't have kinetic energy on there, so it's hard to use this equation directly because we don't know the work function. And they didn't give us the frequency. They said for a frequency of light that has a stopping potential of 3 volts. So stopping potential is associated with that energy. So how you do this one is you simply go over to where the stopping potential is 3 volts and you see where it intersects the line. Okay, and we can see what frequency is associated with that. So what is the connection between, and so I'm going to go down to A, right? What is the connection between kinetic energy max and stopping potential? In other words, what's the general relationship between kinetic energy and any voltage or potential? And that's something going back to earlier in the year where any energy, or actually let me not write it like that, but I'll let you translate it for this one, is relationship between that is Q delta V. Okay, so this can be work, it can be energy, and then Q, of course, is the charge of the electron that's being knocked off. So you now figured out from the graph what the stopping potential is. You can figure out what the kinetic energy of that photon would have to be. Okay, so that's fairly straightforward. You can do your answers in electron volts, that's easier, or you can do it in joules. So it turns out in this one we don't need to know what that frequency is, but it's helpful. It helps us understand what's going on there. Now, it says B, from the graph, find the value, and the value of an electron charge, right? That we'll just call that E. Determine the experimental value of Planck's constant. And so this method, if you go back to the notes we've seen before, is that Planck's constant down here is associated with the slope of the graph. It's not necessarily the slope of the graph, but it is associated with that. Okay, if this was a kinetic energy graph, and then this would be the equation of that graph, then we would see that the Planck's constant is the slope, and the work function would be the y-intercept. But since we have voltage, it's not so simple, but since we made this connection here, okay, we can say, right, that voltage is equal to some slope, something, times F, and then there is the work function there, but that's not going to come into play. So all you have to do is take this relationship, okay, and couple it with the kinetic energy equation and work out what the slope must be equivalent to. In other words, if you take that relationship, we know that energy is HF, or the kinetic energy is HF, and we know that QV is equal to HF, then you can work out how the slope, and the slope from the graph is essentially V over F. You can combine these three to come up with the relationship that connects the slope to H, and then I want you to work that out, what the value is, at least in this particular problem. In C, it says from the graph determine the work function. Okay, there's two ways you can do this. The first one, you could extrapolate or extend the line. Okay, but that's not going to be as accurate. In other words, the work function is the y-intercept, and that would be there. But the problem with that is, okay, that gives you a voltage. It doesn't give you an energy, so you'd have to make a connection between voltage and energy. That could be done. The other way you could do it is algebraically, but remember that the work function is associated when the kinetic energy is 0. Okay? In other words, if you have just enough energy of your incoming photon to get the electron out, but it has 0 leftover kinetic energy, that's equivalent to the work function. So if you take kinetic energy plus, if you take that equation equals HF minus the work function, and you know this is 0, then you can set it up and solve for phi that way. So you might try it both ways and see if it works out. Last one is sketch a graph of the same incident light is shown on the metal with a lower work function. Okay, so we have a different metal. What happens to that graph when we have a lower work function? Well, there's two things that can change about a graph. You can change the slope, you can change the y-intercept. We already know slope is associated with Planck's constant, and Planck's constant isn't changing, and we already said that work function is associated with y-intercept. So that gives us a clue as to what's going to happen, right? We know the slope is the same, but there is going to be a shift. Okay, I will let you work it out as to what direction that shift is. Is it going to be to the left or is it going to be to the right? All right, I think you can work that out. Okay, so that's pretty much what I want to do with the rest of them for this one. All right, it's another problem. It's slightly different. Make sure you set up space. Don't cram it all in here. The way I had to copy it, I just had to put all the questions based on that. I just had to copy it the way it is, and so give yourself a lot of space to do this. It's a similar idea, except that it's not graphical based. And then we have some multiple choice. Should be pretty straightforward. And then just looking at the photoelectric effect a slightly different way. Just giving you multiple ways of looking at it.